it's easy to prove whether the Earth is flat or spherical using 3 boats out at sea.
I can tell by the quality of the artwork here that this is going to be some high IQ science. Hi everyone, and welcome to Jen's Little Corner.
Boat number 1, boat number 2, boat number 3. On boat number 1 we have a large drum of cable or line, and we attach that to boat number 2.
Yeah, okay, I'm with you up to now.
We then drive boat number 1 and 2 in opposite directions.
I know I'm being a little bit pedantic here, but you don't actually drive boats, you sail them.
Leaving boat number 3 in the middle to observe what happens to the cable.
The cable will eventually fall into the water.
Because on a round Earth, that cable will be dragged underwater.
Not to be pedantic again, but if you have, say, 2 boats, and they sail away from each other with a cable in between them, that cable is not being dragged anywhere. It's being unspooled from each boat and staying in exactly the same position. Well, not exactly the same position, because you're talking about boats here that are on water, and water flows and moves, and you have waves, especially if you're on an ocean. But even if you're on a lake, the water still flows and moves. So being able to have a taut cable between 2 boats over any great distance on water or even on land is next to impossible. This is due to the rigidity of objects. Nothing is perfectly rigid, and a cable that's meant to be lax and can be wound up is even less rigid than, say, a solid piece of metal. There is no way in this world that you are going to have a piece of cable that you try to hold in between 2 boats that move away from each other that is not going to dip. Curvature of the world or not, even on a flat Earth, this cable is going to hit the water.
The 2 boats will drive over the curvature of the Earth away from each other. Boat number 1, boat number 2, boat number 3 observes in the middle, and the line kept taut between the 2 boats will be forced underwater.
Well, sure, as I've already explained, this is going to happen regardless of whether we had a round Earth or a flat Earth. Your experiment cannot prove one way or the other, because we cannot have materials that are rigid enough to do the kind of experiment that you want to do, especially if you're talking about cables. You want to know that I'm telling the truth? Go outside and have a look at a couple of power poles. See how the cables dip. It's only when they have them under high tension, usually with weights on the end to continually pull them taut, that those cables are ever anywhere close to being dead straight. Now, if you've got 2 ships sailing away from each other that are unspooling cables on water which is inherently unstable, then there is no way you're going to be able to hold that cable anything close to taut over a long distance. In fact, you are most likely going to break that cable because the tensile strength of that cable is not going to be strong enough to be pulled the way you want it to be pulled over a vast distance. So yes, as a thought experiment, if you could have a strong enough cable, if you had a way you could technically keep it taut, and you could sail those ships far enough away from each other, yes, as you move, the cable will eventually go down into the water. But as I've already explained, the cable's going into the water anyway. This is actually an impossible experiment.
And the 2 boats won't have to drive very far apart, because at 6 miles the boats will appear to be more than 24 feet below the horizon.
Yeah, I'm guessing you're just bouncing the cable on the surface of the water and waiting for it to go under, if you're talking about 6 miles here. No, you'd have to have big ass boats to have this cable on, because this cable's going to have to be like 2-inch diameter steel cable, and to have 6 miles of that is one hell of a big spool. So you need one hell of a big boat, and big boats sit a long way out of the water. So the top of this cable is probably going to easily be 40 foot above the ground. So now you've extended out a little bit further, and your 6 miles has now become nearly 8 miles of cable. So we've got big ships, enormous roll of cable, 8 miles apart. Starting to see a lot of problems with this entire experiment.
If the Earth is flat, then the cable will not seem to budge, apart from the waves and the swell. And this needs to be done out at sea, because a lake is just a dip in the ground with water in it.
You are aware that the whole Earth curves, not just the oceans. So lake surfaces are also curved, so there's nothing stopping you trying to do this experiment on the lake, except for the fact that the experiment doesn't fucking work in the first place, you ignoramus.
The edges of the lake mean that the water remains flat. So do this out at sea. Someone out there must be able to organise 3 boats and a few miles of fishing line.
A few miles of fishing line? A fucking fish can break fishing line on the end of your rod. For goodness sake, dude, you're talking about 2-inch diameter steel cables. You are talking about very large ships. You are talking about an experiment that is physically impossible to do on a flat Earth or a round Earth. Go back to school and learn some physics.
And a GoPro, get it up onto YouTube, prove it once and for all. You don't need a high altitude weather balloon, you don't need a space rocket or a military powered laser, just 3 boats and a long length of fishing line. Good luck, let's see the results.
I can tell you the results right here and now. A broken fishing line, 3 people running boats laughing their fucking ass off at you, and egg all over your face. This is not possible. But if you want some more proof that this is not possible, let's take a look at the weight of that cable and how strong that cable is, and whether it can even survive being pulled like that. Here is some data for some high tensile fiber core steel wire rope. I'm going to do this all in metric because I'm Australian and I prefer the metric system. So the distance that you'd have to have between the 2 ships is about 12,500 meters. And the cable weighs 10 kilograms per meter. So we have 125,000 kilograms of cable. So the force on that cable is the mass times the acceleration due to gravity. Now I know you numpties don't believe in gravity, but that is actually irrelevant to this. There is a downward force of 9.8 meters per second, regardless of what you flirt types think causes it. So the force on this cable is 125,000 kilograms times 9.8 meters per second, which is 1,225,000 newtons, or 1,225 kilonewtons, because to get a kilonewton from a newton you divide by 1,000. Now this is just 220 kilonewtons shy of the breaking point for that cable. Now I hear you. You're going to say, but the cable won't break. But you'd be wrong, because this is only for a cable that isn't under tension. And for your experiment to work, that cable needs to be under a shit ton of tension. And wouldn't you know it, but the minimum amount of tensile force that you would need to apply to that cable to keep it taut is equivalent to the force that is on that cable due to gravity. So the minimum force acting on that cable to keep it perfectly straight over the distance is 2,450 kilonewtons, nearly double the breaking point of the cable. It seems to me that you have egg on your face, no matter how you try to make this omelette. Anyway guys, thank you for watching this video, and if you like it, please give it a thumbs up and subscribe if you haven't already. Oh, and don't forget to click the little bell so you know when I'm making new videos. And please guys, remember, no matter what you're doing with your cables, please don't choke on the selfie stick. This is due to the rigidity. This is due to the rigidity. Oh, fuck me, I can't even say the word. This is due to the rigidity.